All right. Good afternoon, everyone. Welcome to this talk. We have heard a lot of talks today already about developer productivity, and now we have a talk by someone who thinks this topic is important enough to found its own company for this topic. It's my pleasure today to introduce Hans Dockter to you. He's one of the founders and the CEO of the company Gradle. He has been the project lead for the Gradle build tool since the very beginning in 2015, and he is also the pioneer and the world-leading authority on the field of developer productivity engineering. He founded the product Gradle Enterprise, which is a leading technology platform for this practice. He's a thought leader in the field of project automation, and he has been responsible for a large number of enterprise build systems. He's also an advocate of domain-driven design. He has taught classes on this topic and done presentations on the topic with Eric Evans. And in earlier days, he also was a committer for the JBoss project, and he also founded the JBoss IDE. So join me in welcoming Hans Dockter with the talk, Making Developer Toolchains More Efficient.
Yeah, good afternoon, everyone. I'm glad I made it. I'm still a little bit jet-lagged, and so I had an afternoon nap, and I dreamt that I missed my presentation and couldn't find a room. So, first mission accomplished. Yeah, so I want to talk. So first of all, thanks for the introduction. So I want to talk a little bit more before I start with the talk. What brought me to dive into this topic from a cognitive science perspective, right? So as you said, I founded back in the days the Gradle build tool out of frustrations from working, I would say, in low productivity environments, right? So my goal was, how can we make it easier to automate, right, the dialogue with the toolchain, right? Developers, for me, the way I look at it, right, scientists have a dialogue with nature via experiments, and developers have a dialogue with the toolchain, right, to understand whether their hypothesis, which is the code they do, right, is correct. Usually we cannot formally prove that this is the case. So for me, it was always about this dialogue. How can you automate this dialogue? And then once it's automated, right, we work with many companies, right, from Goldman Sachs to Apple to Netflix to LinkedIn, but also non-tech companies, right? We were in the trenches with hundreds of companies when it was about how they can improve their tool chain, and then we saw a lot of problems in that those companies had that went way beyond the particular build system they're using, right? And things like flaky test, reliability, and things like that. And we'll talk later about that. And then that gave us ideas, right? Hey, there's a completely different level of problems that we can address, right? And so we created a product called Gradle Enterprise. It works with Maven, with Gradle, with Bazel, with SPT, right? And more build systems are on the list, right? Considering that the build systems are the entry point, the wrapper around the tool chain where you interact with the tool chain, right? From your IDE, from CI, from your local command line. And what was then interesting is when we could what we considered achieve huge successes, how the business leadership looked at those successes and said, oh, everything is now 2 times faster, but what is the business value of that, right? And I was sometimes astounded by that, so that they questioned that certain things were very valuable, and so it made me think, hey, how can we explain this better? And that led to this talk. Anyhow, so let's get going, right? So yeah, what I want to start with is what I consider the biggest obstacles when it comes towards developer productivity. So we do regular surveys with developers, right? We do tons of events, online events, and we very often ask the question, how much more productive do you think you would be with a more efficient tool chain? And the answer is astonishing, right? I would say more than 80% of the developers say at least 2 times more productive. Quite a few say 3x, 4x, 5x. If there is any truth to that, it would be like transformative, right? I think we can all agree developers being 2 times more productive would be transformative, right? And this is a gut estimate, right, of the developers, but it's still fascinating, right, because it's so consistent, right? So furthermore, one of the things our product does is to instrument the tool chain, right? Whenever you run builds, you run tests, when things are happening on CI, and we do this with companies that have, let's say, LinkedIn, they have 900,000 of those feedback cycles every day, right? And it's really interesting when you look at that data. And that data kind of validates those numbers, but I will talk about that in more details later, right? But in any case, we think there is a huge transformative opportunity. So we also talk a lot with engineering executives, right? And when I started, in whatever, 10 years ago, right, it was fascinating for me how ignored developer productivity was by engineering leadership. It was just maybe developers whining again about something, right? But the waste was so obvious for me, but it was just not on their radar at all, right? It was a complete bottom-up thing we had to do. And it is exciting and encouraging to see that this has changed, right? And over the last 5 years, I would say surprisingly fast. When you look at the large Wall Street banks, for example, they now all have C-level ownership of developer experience. I think DX, right, the new thing, right? And I think that word didn't even exist 4 or 5 years ago. So there has been quite some movement there, which is great, right? But then you have situations, yes, DX is owned by, has C-level ownership, and there's a company, for example, that I have in mind that has 5,000 developers, and now they have 3 people responsible for developer experience. So, nice try. But at least you don't have to perform those things anymore in stealth mode, right? But I would say it's not on the radar, but it's not fully embraced, except for this rare breed of companies that trust the gut of the developers to make massive investments, right? So when you look at Google, when you look at Facebook, but also when you look at Uber, 10 to 20% of the developers work on productivity-related things to make the other 80 to 90% more productive. And that takes guts, right? Imagine you would come to your boss tomorrow and say, I don't know, you have 100 developers, hey, 10 people need to work on productivity. But it would be like, really? Isn't one enough, right? But the fascinating thing is, right, I think if you would make the same comparison, I haven't done it, but I think that would be the case. If you would make the same comparison with the size of their DevOps teams, I think you wouldn't find those huge differences, right? From 0.01%, right, to 20%. It shows the immaturity of the space, and someone must be wrong, right? Someone must be quite wrong. And that's the question, who is wrong? Who is over-investing? Who is under-investing, right? Well, you can imagine, right, where my position is, right? I think there's a huge under-investment happening, and which is not capturing what I really think is the transformative potential, right? So, but why is this the case, right? The goals are aligned, right? It's not like, oh, is it really that important that we ship software faster? There is no, there is no misalignment with leadership and with the developers about the goal, right? Everyone wants to increase output, right? So it's top priority for both developers and leadership. It's what they're passionate about, right? But when the misalignment of what I think about the impact of DPE and improving the tool chain is that developer leadership has less convictions about the impact. They look at it, that this is an incremental opportunity, right? The developers, they are arguing from the guts. They don't have data usually to prove that they would be 2x or 3x more productive, right? And it's a hard thing to communicate to the ones who don't experience that in their daily life. And you know, at one point I stopped coding in my role, right? And the only thing when I went back to coding was, for the fun of it, I wanted to do some of the migration when we moved to Kotlin, right? We have a friend from JetBrains here. That's I mentioned that story. And then I had my first pull request since 5 years, right? And we had quite a few of issue with flaky test. And I said, wow, that's kind of a pain to get my pull request through, right? So even though I'm a developer by heart, that's what I did for many years. I kind of forgot some of the pains that can be associated with that, right? So, and I think the hard problem, or the big problem that we have is there is a lack of models, data and education, right, on how to measure and quantify the opportunity that we have in the field of developer productivity, right? So, one of the big question is, right, how can improving the toolchain really contribute to business value, right? So sometimes I have a situation, right, that we show data to the leadership from the instrumenting the toolchain that developers are waiting in average multiple hours per day for toolchain results, right? And that they get multiple times a day interrupted by flaky tests, right? And they see the value, leadership sees the value of improving that, right? No, they don't say, oh, it would hurt our company if we make this twice as fast, right? But they're still very uncertain how this maps to business value and productivity, right? So, for example, they say, well, they wait 15 minutes, they can answer some emails, all right? When the developers hear that, they're getting crazy. They cannot understand how someone cannot see the value of making things 2, 3, 4 times faster, right? But there is serious doubt in many organizations how this really maps to business value, right? And it's fascinating because from the guts of a developer, it's so obvious. It's screamingly obvious, right? How that would make them productive, but not from very often from business leadership. There was, for example, we work a lot in the Android field, and Android applications are pretty complicated to build. And they also have particular performance issues, right? And for many years, it's the problem Android developers mention as their main problem with the platform is they would like to have faster build and test feedback cycles. By the way, a recent GitHub survey said the same about enterprise developers. They did survey with large enterprises, and the biggest pain point of all the pain points was waiting for builds and tests. The point I want to make is then the Google Android team, they did a lot of improvements, right, to make the experience faster. But for that, the Android teams had to restructure some of their code and their build logic. And then they were doing a large survey with thousands of developers. What is the biggest impediment for you to do those changes? And they said, making the business case to the management. So they often struggle with that, right? And when you cannot make a good case, right, I understand the leadership doubts, right? Hey, if you cannot show me how this creates business value, right, then why should I do that? So how do we resolve that? So to look at this in a very unromantic way, right? I was a developer, and right, we are production resources, right? And to be more precise, not our feet or our biceps, but our brains, right? In a figurative sense, our hearts. So I don't know how big the companies you are where you're coming from, right? There are 100 brains, thousands of brains, right? The biggest software companies, they have 50,000 of brains, right? And and you're paying a lot of money that they provide you their brains, right, to produce software, right? And you want to maximize the output in code and business value from those brains. That's what we're doing. And in other industries, right, be it automotive or chemical, people who are responsible for the production resources are experts in two areas, right? So, for example, in the car industry, I'm an expert in cars, but I'm also an expert in industry robots, right? And in chemistry, I'm an expert in chemistry, but I'm also an expert in chemical apparatuses at scale, etc., right? In our industry, usually, engineering leaders are experts, hopefully, in software, but not in brains, right? When it comes to brains, it's shockingly pedestrian, the knowledge, right? How our brain works, right? It's superficial, it's naive, and that's why people say, well, they wait for 50 minutes, why can't they answer an email? Why is this lost time? That's a very naive model about how our brain works, right? And that is why all those decisions that we're making in this trillion-dollar industry are still driven by guts. The leadership have guts about what makes people productive, right? The developers have a gut feeling. It's very immature. Okay, but there is so much scientific insight into how our brains work. It's called cognitive science, right? And it's an amazing discipline, right? And I really think engineering leaders needs to dive much deeper into cognitive science to understand, what are the impediments of developer productivity. So cognitive science is the key to translating the gut feel of developers into something that doesn't need to be experienced to be believed. So let's get started. So cognitive science tells us that there are two types of cognitive work, right? So the first is learned, effortless routine. And this is when you have input, right? And the input is routed to established neural pathways to achieve a certain goal, right? So when I close my laptop, for example, right? I don't need to think about it. How do I do that? There is an established neural pathway to do that, right? And the second are tasks that require cognitive control, right? Where you have inputs and you have a goal, but you don't have established neural pathways to figure out how to achieve that goal. So you need to figure out the actions to achieve this goal, and that usually happens in the prefrontal cortex. There's a lot of research around that. So an example for the first category is that when we walk, let's say, through a forest, right, we do not run into trees, right? And we can do this for a long time. It's cognitively challenging, right, if you think about it, right, that we can do this, but we don't need cognitive control for that, right? We get exhausted in the muscles before we get exhausted in the brain from doing that, right? But another interesting example is when you look at a professional chess player, right, the opening of a chess game often also falls into that category. I underline professional chess player, right? So they have established neural pathways. They know the opening libraries inside out, right? So they could do opening combinations without making mistakes from morning till evening. Oops, I'm sorry. And so now sticking with the example of chess, right? As a chess game progresses, the space of possibilities exponentially increases, and you can no longer rely on learned routine. And you need to switch as a chess player to cognitive control. And this is where the most games are won or lost. It's a separate part of the brain, as I said, that is responsible for that, right? And that is where, when you do studies with chess players, where cognitive fatigue sets in at a certain point, right? And they will, after several hours, right, they will start making mistakes they wouldn't have made at the beginning, right, when they were still fresh. So cognitive fatigue is the key term of this keynote, and I think this is the major reason why many of your companies might be far away from delivering the amount of software and innovation that you could but you potentially could. So again, learned effortless routine is not leading to cognitive fatigue, right? But cognitive control is leading to cognitive fatigue. Now think about, so I think with a chess player it's about 4 to 5 hours when this sets in. Now imagine the chess player would get phone calls, had to answer Slack messages, arbitrary changes in the position of the board, how much faster the cognitive fatigue would set in, right? And you can already see the connection to software development, right? But in general, cognitive fatigue is great, right? The ideal world is, right, people doing innovative, high-quality software development in the morning, right? And then at the end of the business day, they're cognitively fatigued, and that fatigue has resulted in wonderful code in your Git repository, right? That's the deal. I go home happy because I feel fulfilled, right? The leadership is happy because they get what they're paying for, right? That's where we want to be. And then rinse and repeat the next day. So, okay, unfortunately, that's not the case, right? And one reason is multitasking, right? We are all forced to do much more multitasking than we should be to be productive, right? And I will talk about that very soon in detail when it comes to the developer toolchain. But there is a multitasking myth, right? Many people in leadership positions have to multitask a lot, right? And many people think multitasking is a skill that can be acquired, right? Many people claim to be quite good at it, right? For some, it's one of the most important skills in today's world. People think the younger generations are particularly good at it, right? My wife thinks that women are better at that than men, right? So I'm 9,000 miles away. I can say this now here, none of that is the case. None of that, right? There's so many studies around that. I just listed a few here, right? You have a multitasking group, right, that has different tasks to accomplish at the same time, and compare the results with another group that was instructed to do only one thing at a time, and the outcome is unambiguous, right? It's so evident. The productivity of the multitasking group was lower, but not only the quantity was worse, but also the quality, right? Consistently, and by a large degree. Right? Multitasking is just not an efficient way of working, right? Cognitive science is so clear about this. So at the same time, when you ask the multitaskers, hey, were you productive? They said, yeah, great, we did a great job, in those studies, right? And that's fascinating, right? And so why do those especially the leaders, confident people, very often do think they're particularly good at multitasking, right? So first of all, in my daily life, I don't have a control group that can say, okay, let's clone me and see how productive I am without multitasking, right? So that would be very useful feedback. But the second is I wished, so also as a developer, I was always dreaming if I had some quantity that tells me how productive I am at the moment, right? We can be so delusional about that. The second is what psychologists call the mere exposure effect. Doing something many times, and then we're even successful, we get a big salary, right? How can we not be great in the work we're doing, right? So it makes us believe we have become good at it, right? Completely independent of our actual performance, right? So we unfortunately tend to confuse familiarity with skill, right? We're good at it. No, we do it every day. We suck at it like every human brain in the world, right? But that's a hard thing to admit, right? So, but that is a key area, right, where gut feel of developers and gut feel of leaders heavily collide, right? And the leaders make the decision, are we investing 10% into the toolchain, right, to improve it, or only 0.01%, right? So, so let's come back to software, right? So developing software obviously requires cognitive control and induces cognitive fatigue. I think we can all agree on that, right? Maybe not Elon Musk, right, but the rest of the world. So, yeah, I'm referring to his hardcore kind of development style he's promoting, right, where it's all willpower, right, and there is no cognitive fatigue, right? So, but not all of software development, and that becomes pretty important later on, induces cognitive fatigue, right? Trivial refactoring does not require it, right? JetBrains and IntelliJ is making that easy for me, right? But the parts that require cognitive controls are the parts why we are getting paid what we're getting paid. I think that's fair to say, right? So, and cognitive fatigue is the reason why the potential of improving the tool chain is transformative and not incremental. If there were no cognitive fatigue, right, then the ROI of that would be actually much lower, right? And one important thing about cognitive fatigue is that we talk about that when you switch tasks. Just the fact that you switch from one task to the other, you have to create a new pattern in your prefrontal cortex. Just creating that new pattern accelerates cognitive fatigue, right? And that is the reason why multitasking is just not very productive, right? Because you have to create this fascinating, right, a pattern that is able to map inputs to goals, right? And depending on the problem, you need a completely new pattern, right? So cognitive fatigue, as I said, is the reason why the potential of DPE is transformative, right, and not incremental. And in many of the naive and wrong models I encounter with leaders, right, they don't get that, right? They've never heard about it, right? So let's talk about the value of. So when I haven't even introduced the term DPE. So DPE is developer productivity engineering. It's what every other industry is doing, right? Having an engineering approach to the productivity aspect of software development, right? Versus gut-driven, non-data-driven approach that we have today. So the big goal, right, when it comes to developer productivity and related to the tool chain is, one is less non-productive time. So, for example, reducing wait time, right? It's pretty obvious. The second is a lower percentage of the workday under cognitive fatigue, right? They're related, right? But they're not the same. I will talk about that in a second, right? So less non-productive time, lower percentage of the workday under cognitive fatigue. How do we get there, right? So to achieve this, we need to improve the following metrics. One is that's I would say the most harmless one: troubleshooting time of code verification failures. So I have a dialogue with my toolchain. My toolchain says me, "Hey, something is wrong with your code," and it's actually true, right? Let's assume that it's not a flaky test, right? So we just want to accelerate troubleshooting them, right? And what we see in many organizations, I'm not sure how your organization looks like. Let's say you have a failed pull request built on CI. Many developers are wondering, is it really me? Right? Is it a CI environment, right? Is it a flaky test? Is my, is the test database kind of screwed up again, right? So just that fact, right, that is a hard thing to figure out, right? Let alone how frustrating it is, right? So we distinguish between verification failures and toolchain failures, right? A verification failure is why we write tests, right? They tell us that is a failure that really detects a problem with the code that we just submitted, right? And then a toolchain failure is, for example, a flaky test or an out-of-memory exception when the build is running, whatever, right? You don't want them, but you have them. The other one is feedback time. That's pretty obvious, right? And then lastly, troubleshooting time of toolchain failures, right? Things like flaky test, flaky builds, dependency download errors, corrupt CI environments, right? And of course, what is the best way to reduce the troubleshooting time of toolchain failures? To prevent them altogether, right? But if you have them, then at least make it easy to detect them, right? I mean, this, I'm not sure, this is a serious problem, just that people don't know. I mean, we talk with so many CI teams, right? The finger pointing, it's me, it's you, who is it, who should even look into this problem, right, is significant, right? And we see this at almost every company we're working with, right? So, okay, code verification failures. Let's dive a little bit deeper into them, right? They are great, right? This is why we write tests, right? We want to have them. That is why we have a dialogue with the toolchain, right? All together, right? So what is causing unnecessary cognitive fatigue is when it's hard to figure out the root cause of that failure. So I just give you an idea to what depth some companies are going. Spotify has an amazing developer productivity team, right? And one key metric they are going to they are working on improving is to reduce the number of clicks when there is a problem, right, in a CI build for the developer to understand what the problem is, right? So just to give you an idea, right? So there is stuff you can do that is relevant, very relevant, but those are the most harmless ones, right? The key thing is that you can trust whether it's really a code verification failure. So now we come to an interesting one. So feedback time is strongly correlated with task switching, right? So what you commonly see is when feedback cycle time is less than 10 minutes, that people wait for the feedback, right? They don't do anything else, right? So are they lazy, right? Do they just want to drink coffee? No, wait time, and that's super important to understand, is a strategy against task switching, right? And accelerated cognitive fatigue. Switching tasks accelerates cognitive fatigue, right? Many experiments in cognitive science, right? It's very easy to do those experiments, right? If you're interested, look at some of the studies, right? They do them all the time, right? And there are even some Android apps or iOS apps where you can do those experiments and you can experience yourself, right? So people want to. So if people wait for feedback, they made an active decision to do so to avoid task switching, right? It's an active strategy, right? They do not enjoy waiting, right? And if some engineering leader naively thinks that time can be used for doing productive work, they're completely missing that point, right? And that is a discussion I frequently have, right? So from a developer perspective, waiting is the optimal productivity strategy, and obviously reducing, going from 8 to 7, going from 8 to 5 is worth gold, right? And the interesting, right, one very interesting point is the lack of insights companies have into the feedback cycles. I mean, I was talking with a large car maker, right? They were inviting us to talk about developer productivity, and I asked them a very innocent question, right? So how many feedback cycles do your developers have per day? What is the average time of the feedback cycle? How often do they fail? And the answer I got was, well, we have to do a survey. And I said, if I went to your factory and I would get that answer from the guy in the factory, how long does it take, whatever, right? It would be a deepest violation of your culture not to have this answer within 10 seconds, right? But in software, you have to do a survey. I mean, right? Imagine now you would ask the question, yes, okay, so how much is annotation processor X contributing to the feedback cycle time on Sunday for your team in India, right? They would look at you as if you're crazy, although it's a completely reasonable question to ask, right? They have no data, right? And, well, I'm saying they look at me, you're part of that, right? If I would ask you that question, you would say, well, I don't know, I guess, right? That's my experience. I feel pretty confident about that you wouldn't know, right? Including the local builds all your folks are running. How many local builds are your developers are running? No idea, right? How often do they fail? No idea, right? So, and developers have surrendered. They no longer report all those problems they get, right? Because nobody does anything about them anyhow, right? So anyhow, right? And so, but for example, we were working, TNG is Atlassian partner, we were working with a team at Atlassian, a small Android team, right? They have many Android teams. 5-people team had a 1-minute build and test time. So no one would probably be complaining about a 1-minute build and test time, right? So, but we got it down to 0.6 minutes, and they run 1,000 times a week. So I hope everyone agrees when something takes 1 minute, you wait, I guess, right? And for this 5-people team, getting it down from 1 minute to 0.6 minute meant 44 days of reduced waiting time per year. Now we're talking, right? If you ask someone, right, 1 minute to 0.6 minute, is that transformative, right? Well, it's 44 days more productivity, right? Just with that improvement, right? So it's huge, right? But to make that decision, you need the data. When you have to do a survey to figure out, right, how often you run the feedback cycles, right, that then the decision-making process will be hard, right? So what becomes interesting with longer feedback cycle time, right? Waiting has become less and less the optimal productivity strategy. We work with one large organization. They have an overall feedback cycle time of 24 hours, right? So if you're waiting for that, right, you will not get much done. So developers start to do task switching, right, and work on multiple tasks in parallel, right? So the longer the feedback cycle time is, right, the more tasks they will be working on in parallel, right? It's a function, basically, right? And the more tasks in parallel, the more often you get interrupted by toolchain events, right? If you start working on 5, 6 things, right, you have multiple pull requests going, right, then you work on one thing, and then email, pull request build failed. So now you have to switch back. You get the idea, right? If you lived in a happy world, right, and all your changes where you never had any mistakes, it would not be a problem, right? You just fire up all this pull request build, and they all get successfully merged, right? There will be no interruption, but that's usually not how things are going, right? So because of that, you have much more context switching to do, right? And therefore you have accelerated cognitive fatigue. You will get less done in a given amount of time compared to finishing one task after another, right? So again, if there were no cognitive fatigue, task switching would be inexpensive, feedback cycle time can always be used productively, it would be a different world, right? But if we don't need to sleep, we would also be more productive, but we have to sleep, right? It's just a biological fact, right? We cannot ignore. So therefore, it's not a subjective feeling of developers that they cannot just overcome if they just try harder, right? It's a biological fact. There's still, the fascinating thing is, we're still not sure what exactly causes cognitive fatigue. There are various theories, various studies, right? So there's still a topic of research, but that it exists, there's no question about it, right? And I think just our common sense tells us, right, that there is something like cognitive fatigue. Okay, so toolchain failures, they're the worst, right? They're terrible for so many reasons. They cause task switching, right? Events and fatigue acceleration, right? And they're in particularly bad because the problem is not related to the code base, but a completely different domain, right, when you have a toolchain failure. So you really need to get in a completely different world to understand, right, and to fix it, right? And any troubleshooting, right, is zero productive downtime. If you troubleshoot your code verification failures, you make your code better, right? If you troubleshoot a toolchain failure, right, it shouldn't be there in the first place, right? So, and it takes time too often to debug them. So the task switching accelerated cognitive fatigue, and then the troubleshooting itself is causing cognitive fatigue, right? So one thing where some people get confused, right? There's task switching, and I'm not against multiple streams of work, right? Let's say probably most famous authors, right, or not just famous authors, right, will probably work on multiple manuscripts over the course of a week, right, or a month or a year, right? Sometimes you write the first chapter, and then you're kind of done with it, right, and you have some closure, and your brain needs to get into a different state, different kind of focus. You go to the next manuscript, right? And in software, same thing, right? I'm not saying we should never have parallel things to be working on, but it's our decision when we switch, right? It's not a forced interruption. There is a lot of interesting research also around different types of focus the brain can have, and sometimes you have to get into a different kind of focus to make progress on a certain task, right? And anyhow, so just to make that clear, right? So there's another intriguing aspect when it comes to cognitive fatigue, right? So how do they measure fatigue in cognitive science experiments? It's an interesting question, right? So they found that asking someone whether they are fatigued is not a good metric, right? Fatigued me? Never, right? I want to race. So it's too subjective, right? What they do is they offer participants different tasks, right? Low cognitive cost, low reward task, let's say $1, right? And high cognitive cost, high reward task. If you solve them, you get $10, right? And if cognitive fatigue sets in, people move to low cognitive cost, low reward task, right? That is how they measure it. Fascinating, right? And so let's translate that to software development, right? So there might be, so let's say all your developers are fatigued. There will still be a lot of development activity going on, right? Your bosses will be happy, so much GitHub commits, right? But it will be all, low reward stuff, right? This refactoring, rename the variable or whatever, right? So low value. So, and at the moment, I don't know if you have the same term here in Germany, in the US, everyone is talking about productivity paranoia, right? Especially with remote work. The leadership is freaking out, are my developers productive, right? So they're looking for all kind of metrics, right, to figure out, are they actually productive, right? It's pretty, and in the US, it's completely, you have no constraints, right, what you can collect from a developer's laptop, right? Nothing, right? You can check whatever the hell you want, right? So, and they do this, right? So, well, not us, but quite a few companies do this, right? So you think they're all active, but you not get the value, right? Because they're fatigued, they're not doing innovative, they're not doing creative work, right? That is super important to keep in mind, right? So now imagine a future where lower cognitive tasks are done by ChatGPT or similar models, right? The competitive advantage of having people in non-cognitive fatigue state will even be bigger, right? Because the low cognitive tasks also have to be done by organizations with a high productivity because they need to be done. If they're taken away from them, then those people work even longer on innovative features in non-cognitive fatigue state, whereas the company that has 3 people working on a productivity of 5,000 developers will probably be in a different situation. Right? So, yeah, anyhow, that's why I'm convinced that having an engineering approach to developer productivity, instrumenting your toolchain, not doing surveys, having real data, right, and then applying a lot of techniques, right, that are out there, right, to make the toolchain faster, to reduce the number of flaky tests. There is to massively improve the signal versus noise ratio, right, to actually shift left, right, that developers can get feedback early, right, with smaller change requests, right, instead of what we're seeing now, that actually many teams shifting right because the feedback cycle is getting longer and longer. It's so hard to get something to the tool chain and to a pull request build, so they're accumulating large chain sets, right, to try to get them through instead of working with smaller chain sets. All of that, right, there's great technology out there. To achieve that, but you need to invest into this. And this technology is not like necessarily plug and play. You need to have people that constantly look at the data, right? And in other industries, it's of course you need to have a certain number of chemical process engineers in your chemical factory who look at the data all the time. I mean, there's a culture around that, and we don't have that culture around yet in software, right? Which is ridiculous because software is often what is driving the productivity in the other industries. But when we ask the most simple question about our productivity, people don't have even the data, right? So, so that's That's the immaturity I'm referring to, right? There's not even an academic discipline around that. Can you do a PhD, right, in developer productivity? I'm sure the cognitive depth is there in that area, right? There are only a few computer scientists who are doing research around that, right? It's has to change, right? So, yeah, one thing we have created is a DPE maturity model, right? If you Google for that, you will find it. I don't have time to go today to go through this, right? But it might be an interesting exercise for you to map your organization where you are, right, on that list, right? So, I'm out of time. I just grabbed 3 more minutes. Oh, I have 2 more minutes. Great. Bonus minutes. I'm not fatigued yet. One thing I see over and over again is that DPE initiatives are only happening because of the heroics of some individuals, right? And they do this as a side job because they care so much about it. And every function in a company, right, in our company that relies on heroics makes me very nervous and is a red flag. It might be needed at a certain point in time to make progress, but it's not sustainable. I think we can all agree on that, right? So, but again, those heroics are usually appreciated, but leadership lacks conviction, right, to turn this in a sufficiently funded practice, right? That's the problem. It's, again, the conviction. Is it transformative or is it only incremental? And then we see other, for me, let's say, pathological pattern, right? So, there are so many low-cost, high-reward opportunities to improve the toolchain, right? For example, adding a build cache, right, to your build, for example. I mean, any organization who's not doing that, you're wasting so much money, right? And yet, most people probably are not doing this yet, right? And it doesn't make any sense, right? Any sense. So, and it's even not that much effort, right? But what I see over and over is the following, right? So the leadership is often willing to invest into fixing the most burning problems, right? So it's a reactive firefighting mentality. And then the developers or the DPE teams want to do something much more strategic. So they hide any low-cost, high-reward opportunities, right? They say, oh, I'll give you an example. They say, okay, we have this, let's say, this Maven build, right? We could just add a build cache and it would be 10 times faster. But we want to switch, we think, it will be strategically much better to switch to another build system. Don't mention any names. So, and hey, we support Maven with Gradle Enterprise. We're happy, right? Half of our customers are using Maven. But in any point, so they said, let's not tell them, and we see this all. Let's not tell the leadership that there is a low-cost thing to make the Maven build faster. Just pretend that the only way to make this faster is to do this massive migration. Because if we make the Maven build faster, we will never get the permission to do something more strategic, right? So that is how you try to sneak things in. And fuck, man, is that really how we should be working, right? And I know why people are doing this, but it's like, you know, again, it's a sign of immaturity, right? If we think the migration has a lot of strategic value, right, we should be able to make the case. So in closing, right, there is no developer experience, right? You can do as many surveys as you want, right, if you do not apply engineering approach to making your toolchain better, right? You cannot have a great experience. So, and developers in low productivity environments, right, they're not happy with their job, right, and when they're happy with their job, they're more productive, right? So again, huge opportunity to look into this whole field. There is a book, a DPE handbook that we've written if you want to learn more about the whole practice, and almost done in time. Thank you very much.
Yeah, so thank you very much for this inspiring talk. We still have a couple of minutes for questions. So I want to mention for the remote audience or for the people who are shy, you can also ask questions in Slack. But if you are here and want to have a question, then now is the time to raise your hand.
Thanks for the talk. I just wondered, so toolchain failures. So obviously we want to get them down to the lowest number we can, but in reality, I guess that's not always possible, right? I guess there are some failures you cannot avoid, and at some point you will be hitting diminishing returns. So if you had to put a number on that, is there some kind of natural limit? Like what kind of ratio of failures would you still accept? Or what would you aim for in an ideal but still realistic setting?
Yeah, good question, right? So first of all, failures, right? Verification failures are good. What we usually see is there is around 20%, right, of feedback cycle attempts fail. Much more than probably most people think here, right? Because of failures. And if they're all code verification failures, great, right? So, and then, every test would be flaky, right, over 1 million years, right? So let's say you have a test that is flaky once a million year. Should you invest making it once every 2 million years, right? Probably the answer is no, right? But I don't, so what we are measuring, right, is how often flakiness is impacting the builds. And I think it should be, I don't have good data yet that I could say, hey, but it should be a rare, there are two things that we need, right? It should be a rare event that you have flakiness, right? It should be, that's haven't seen that for a while. And second, even more important, it has to be clear that it's a flaky event. So that is often the problem is not just the flakiness, the problem is you don't know, is that a flaky event or code verification failure, right? And I think that is causing the most problems. So what we are working on, for example, right, we already do a lot of failure analytics, right? We analyze every local and CI build test failure, right, to give you an idea because of the history that we have, hey, this is most likely something flaky, right? For example, a test. But we're working on using machine learning to give you a high level of confidence to say code-related failure, build-related failure, CI-related failure. And I think that if we have that, the situation will have already much improved. Right? I cannot give you a better answer, right? But yeah. And so that is one thing, for example, Spotify is doing, right? They have identified that I would say a large 90% number of all their CI failures is related to 20 typical exception patterns, right? And now they're analyzing the stack trace, right? And when there is a failed build with that pattern, they send an email to the developer, ignore it, right? And then they kill the build environment on the CI machine and run the build again. Otherwise, they will reuse the environment in the local state, in contrast to most other organizations that went to ephemeral CI and now having long CI build times. Yeah.
So I think based on the reaction from the audience, most of the ideas that you've presented today are like this, sorry. So based on the reactions, most of the ideas are like maybe not surprising to many people here, but how do you communicate these ideas succinctly to a business leader who thinks that developers are sponges from which code can be squeezed?
Yes, I think, so the key thing we are always developing is a return on investment model, right? So we instrument the toolchain, right, in everything in the tool. And then we can show you, first of all, how many builds are run, right? What is the average waiting time? How many flaky incidents, right? And then we take, hey, how much are you paying your developers, right? And then we have a quantitative model to say, this is the money you're leaving on the table, right? And we're saying, look, this is only the direct money, right? Where basically your developers are non-productive. This doesn't include longer time to market, right? We cannot quantify how much the company will make if they're faster with shipping the software. This is just the productivity cost you're wasting, right? Your investment cost. And that is usually, that is easily 10x, right? What we show for most organizations, sometimes 20x, sometimes more than that, right? So it's usually a pretty simple case, unless someone says, well, when we reduce the wait time, are they actually working more, right? But then I think, well, then there is no trust at all, right? Then it becomes a harder discussion, right? But that's how we're doing successfully, right? And it's pretty straightforward to do that. So if you're interested, just shoot me an email, right? I could share, we have such an ROI model on our website. Yes, please. Oh, sorry, that is already.
Yeah, yeah. Thanks. First of all, thanks for the fantastic simplicity of the message. So that was really cool. What I was wondering, do you have specific advice? You touched it already a bit on what would you measure first. So you're starting in an environment. You have probably a very mature build system, CI, and all that. But there's room for improvement. Do you have typical ideas? What would you start measuring and how?
Yes. So okay. Now this moves into a little bit of a product pitch, right? But you asked for it. So what we would do, right, is we would we have extensions for for Maven, Gradle, Bazel, SPT, soon also NPM, right? That we would integrate into your local builds and your CI builds, right? And what those extensions are doing, they're deeply instrumental, right? They're not just scrubbing the log file, right? They're getting deep into the toolchain to get information out that is not available anywhere else, right? So to really give you a good idea of where all the time is going and where the non-reliability is, right? So that is where I would always start with, right? Get the data, because it is such a, for me, it's a little bit like performance optimization, right? When you don't do profiling, right, people have all this hypothesis. Why is it, and they're so confident about it, and usually the hypothesis is always wrong once you start looking at the data, right? It's the same thing here, right? And including, IDE is also an interesting part of that. And then we can start having a discussion, right, where the actual problems are, right? And is it test execution time, right? For example, we had an organization, 1,000 developer, large Maven monorepo build, right? And organization with a lot of money, right? They had no lack of resources. And I said, the CI builds are so long, right? And the CI team had no insights into the local build. So they said, wow, it's so long, what should we do, right? The CI build was over an hour, right? And they were thinking about migrating the build. That's why they contacted us, right? They want to migrate to Gradle. We said, let's say we also can do something for Maven. And we collected the data and for the local builds and the CI builds. And it's very stupid, right? But we see this all over the place. Wow, the Maven assembly task that is building the jar files took a minute on the local machines and 40 minutes on the CI machines. Well, what about SSD drives for CI? And their build was 40 minutes faster. But because they only had, there was only the CI team, they didn't look at the local build. Right? There's so many low-hanging fruits, but you just don't have the data, right? So that's how I would say. Then you can reason about things, and then there are so many things, right? There is predictive test selection, machine learning to make, to execute a significant less number of tests. There is build caching. There is distributing your test, right? There is another example, right? There was don't want to mention the name, right? But a large tech company, right? And they were having some centralized plugins, right, for their builds. And they were, in the older days, they were doing still stuff with Ruby, and they were having this Ruby gem task that was taking a minute, right, to run. And a centralized plugin injected that in every build. They had 500,000 and more builds per day, right? And no, it was no longer needed. It was doing nothing except using 1 minute, right? And they completely forgot about it, and it was running in every build. So there's so many things like that. Without visibility, you can go. It's just impossible, right? So and from there are then many avenues depending on what your specific problems are. My favorite one, though, was we instrumented one. Just have to share that because it's funny. Usually we see 20% failures in the toolchain, and we think that's healthy, right? Because those are the tests you're running. I said, you only have 1% failures, right, of your build. Do you have good test coverage? They said, yeah. But we only hire the best developers. They're not making many mistakes. I said, okay, that's an interesting way of interpreting this data. But anyhow.
So one final short question.
Yeah. Oh.
Yeah, I don't know. Is it okay, maybe? Thanks also, very eye-opening message. I was wondering, since you're measuring, I mean, I know it's about improving the toolchain, but since you're measuring developer productivity, how much do you know about like other factors that influence developer productivity, such as the development model, access to knowledge, whatever
Yes.
other factors in the organization.
It's the holy grail, right? And there is, so we call, what we're doing, we call DPE, but then there is also what we call DPM, Developer Productivity Management, right? And there are efforts out there, right, to measure things like, what LinkedIn is measuring, it's always commit to deploy, right? To at least get a higher perspective, right? And then you can look at what takes all the time. So for example, we work with one large bank, right? And their biggest problem was not the tool chain, it was all the manual security steps they had, why it took 30 days to release something. So for them now, to make their builds and tests faster, unfortunately, right, for us, it was like not the most important thing, right? For them it was, hey, we have so many processes here that slow things down, and what do we have to do about that, right? So there are other initiatives that somehow trying to measure the whole velocity, right? And then with that data trying to understand where is it coming from. Of course, the area is not related to the tool chain, right? But that's not our focus. So basically what we are doing is saying there's obvious obstacles from the tool chain, right? We measure how big they are, and then we try to not fully remove them, as you already pointed out, but significantly reduce them. There was one more question. Okay, perfect. Good.
Right. Thanks again for the interesting talk and the interesting questions, question and answer part with all the interesting anecdotes. So this was the last session before the dinner break. Now there's again dinner in all the usual places as before. So if there's a line in some place, try one of the other places. That might be a better strategy. All right, then. Thanks again, and let's thank you again our speaker.
It was a nice ending.